Lowest cost weekly meal plan. You're a college student trying to eat healthy for the week while staying on a tight budget. You want to choose quantities of a few common grocery items to meet basic nutrition needs at the lowest possible weekly cost. You want your diet to provide at least 10,000 calories, 400 grams of protein, and 150 grams of fiber. For variety, you want between 5 and 20 servings of each item. So we're going to seed the decision variables with 2's. These are the decision variables. How do I know that? We've got heading conventions here. So red, these are decision variables. Yellow, these are constraints, 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 constraints. Green, that's our objective function. Actually, that's the bottom line. That's the number we're trying to find. We know we've solved when we get that number. So we get that number, but we also need these numbers because it's these numbers that are going to change to produce that final number. And then finally, gray or orange cells, those are these intermediate calculation cells. So we have some of those here. And after successfully running Solver, we're going to create a named range. This is part of our documentation. A named range from every colored heading in its data, and you'll see me do that at the end here. All right, so first we need to set up the problem. And we'll begin by taking our decision variables and seeding those with 2's. Now, you'll notice that when I do that, they turn pink. In other words, it's wrong. That's not the final answer. And there's a note here that says pink until solved, because Solver is actually going to change those 2's into other numbers to satisfy the objective function here, subject to the constraints, which we're about to define. So, what are the constraints? Since I'm in this section, I'll continue here. It says for variety, you want between 5 and 20 servings of each item. So the minimum number of servings is 5. And the maximum number of servings is 20. And I can actually just copy that down. All right, and now we need the sign. So these are inequalities. So what's going on here? We want the number of servings is going to be greater than or equal to the minimum. We can copy that down. And the number of servings is going to be less than or equal to the maximum. Copy that down too. All right, now what about our nutrition totals? So for example, eggs have 140 calories, 12 grams of protein, 0 grams of fiber, that kind of thing. And so we want the total amount of calories we can get, protein, fiber, etc. How is that total going to be arrived at? Well, it's going to take these numbers here and multiply it by the number of servings. We'll do that for each line and add them all up. And fortunately, there's a function in Excel that does all that in one step called sum product. And you simply feed it the 2 arrays. So here's the first one. Then you put a comma. Then you give it the second array, which is this one. Now, because I'm going to copy this function, I'm also going to lock the range on the servings array, but not the first one, because otherwise it won't copy properly. So I lock that, close the parentheses, hit enter. And now I can copy that across, and you'll see exactly why I locked it. It's so that this one moved, that one didn't, and similarly over here, this one moved, that one didn't. Okay, and then these are going to be greater than, right, the minimum. And so the minimums given in the problem are 10,000 for calories, 400 for protein. This is for the week, not per day. And then 150 for fiber. All right, and then our objective here is to get a minimum total cost. And this now is where we actually run solver. And we have some help in some of the settings for solver here, and we'll get to that in a second. But let's first start up solver. And remember, if this is your first time, you're going to need to install solver using the same technique that you use to install the data analysis tool pack. If you're on a Windows machine, it'll be like file, options, and so forth till you get to Excel add-ins. And on a Mac, it's a little bit more direct to get to the add-ins. All right. Here on a Mac, you simply go Tool, Excel add-ins, and make sure that solver is checked. Okay. So I'm in this cell, launch solver, and when solver first launches, I have to set these settings. Let me to match the what was on this little cheat sheet over here. I happen to know what they are, so I'll go ahead and do it. So first, where it says select solving method, that has to be simplex for this class. And then when you click on the options tab, this first one should say 1e minus 06, or it might instead say 0.000001, in other words, 5 zeros and a 1, which would be the same thing. We use automatic scaling, and then we uncheck these two options, show iteration results and ignore integer constraints. So think of it this way as check, uncheck, uncheck. And then for integer optimality, we set that to 0 because we actually like integers, and that'll help us get closer to integers. And then in maximum time is seconds, we're going to put 10. And we're only doing that so that if you accidentally put in the constraints wrong and you end up in an infinite loop, it won't just stay there working forever. So click OK. All right. Now we're ready to set up the rest of solver. So we want a minimum. So we click the min button. And again, if you're on a Mac and you don't see that radio button, then do this right at the end to at least get that highlighting just before you click solve. By changing variable cells, and so the variable cells are our decision cells. So I'll go ahead and click on this and then highlight the decision cells. Those are the ones that are going to be changed. Subject to the constraints. What are the constraints? Okay, so we've got a bunch of constraints. So the way that we mentioned before, and I'm going to try to stay true to it, is that we always put the constraint on the right-hand side, so the yellow cell on the right-hand side. So in this case, it's going to be these items here, okay, in relation to the minimum. So in relation to the minimum, these are going to be greater than, right? If you read this way along the sign, this is greater than that, okay, are going to be greater than minimum servings, like that. And it's really cool that you can do all of them at the same time. And the second constraint is that that same group of decision cells is going to be, this time the sign is correct direction, is going to be less than or equal to the yellow constraint, which are the maximum servings. All right, and then we have one last set of constraints, which are these intermediate calculations, which are kind of gray-orange cells, so they go on the left also. So these intermediate calculations are going to be greater than or equal to the minimum nutrition mix values. Click OK. Now we've got all our constraints. As I mentioned before, when we got to options, those are the options that we set just a minute ago, and you can do the options last if you want. That's okay too. And then you go ahead and click Solve. Okay, but I got an error. Objective cell contents must be a formula. And what it's complaining about, so I'm going to close Solver and fix it. What it's complaining about is that this also has to have a function. So sum product. And this is going to be the cost per serving times the number of servings, and then all of those subtotals added up. I don't have to lock either of these ranges because I'm not going to copy this function. Okay, now, so that's going to be the value with 2's here, but now I'm going to run solver again to get the real value. And it says solver found a solution. Sometimes it'll tell you solver didn't find a solution, and that's bad news because that means that, at least on the problems that we give you, it means you probably didn't set it up right. All constraints are satisfied, so we'll click OK. And then it puts in the solution, and notice that it put these values to where they should be in order to get this solution. How do we know this solution is good? Well, it's because all of these values are subject to the constraints. 5 is less than or equal to 5, and less than or equal to 20, and so forth. 20 is greater than or equal to 5. Sorry, I said the first one wrong. 20 is greater than or equal to 5, and 20 is less than or equal to 20. So each of these numbers is literally in the middle. These are called goalpost constraints, when you have a minimum and a maximum for the same number. So you're sort of like kicking a field goal. You're trying to stay between the goalposts. And you don't care where you are between the goalposts, as long as you're between the goalposts. And then over here, these are one-way constraints. It's just that we had to be greater than or equal to 10,000, so that calculation worked. Greater than or equal to 400, this one worked. And greater than or equal to 150, so this one worked. So all the constraints were satisfied, which was exactly what solver was telling us. All right, now let's make this a little bit bigger. Again, this is the cheat sheet from when you were doing the options in solver. And now we're ready to do our documentation. And the documentation is really, in solver, is really pretty cool. The way that we're going to do it is we're going to take every heading that is colored and its associated data and highlight it. So here's a yellow heading. And then we're going to go to the Formulas tab and pick Create from Selection. And it says Create Names in top row. So I click OK. Now, what's the effect of that? Because it doesn't look like anything happened, but I'm going to show you what happened. What it did is it took these 5 cells and collectively gave them a name. Not the heading. It got the name from the heading, but it gave that name to these 5 cells. Can I prove that? Sure I can. If I actually highlight these 5 cells and I look over here in the name box, it turns out that it did give the name minimum servings to those 5 cells taken together. Like if I click on any one of them, the name goes away. That name refers to all 5 of them together. And you'll see why this is important in just a second. All right, same thing here. Highlight, Create from Selection, and highlight, Create from Selection, and highlight, Create from Selection. And notice here, if the name is in the leftmost column, it figures that out, which is kind of cool. And highlight, Create from Selection. And then finally with total cost, we'll do the same thing. Highlight and Create from Selection. All right, now, what's the big deal behind all of that? The big deal is that we can actually have it output those names over here. So we click here under Name, and then from that same Formulas tab, we go to Formulas, and then Use in Formula, Paste Names, Paste List. And this now shows, for documentation purposes, what all of these named ranges refer to. And so you're thinking, okay, fine, but so what? Here's the so what. I'm going to go back to Solver. And now you see that Solver actually picked up those names and put them right here. And this is incredibly cool. So I'm going to do a screen grab of that on either Mac or Windows, whichever one you're on. I'm going to copy that, then close Solver, and paste that right here. And the advantage to doing all this, the reason that we do all this is because when we come back to a problem and we're saying, okay, how does this all work together? We can say, okay, does this make sense? Right, the way that these constraints are set up. And if we're trying to find out, well, what's wrong with Solver, this allows us to see what all these named ranges referred to and how the entire problem was set up. So it provides beautiful documentation. Okay, we'll see you in the next video.